And I've got to remember to change the camera over about every 20 minutes so I don't go over 33 minutes. Don't know why that happens, but it does. So, if we go to three dimensions with 4 points, well, we have the area of the triangle is the determinant of x1, x2, 1, x1, y1, 1, x2, y2, 1, x3, y3, 1. We add a coordinate, we add z. And we also add a fourth row. Well, if we extend this matrix by adding a z column and a fourth row, what's the obvious thing? We have x1, y1, z1, 1, x2, y2, z2, 2, x3, y3, z3, 3, x4, y4, z4, 4, where x1, y1, z1 is coordinates of our first point, x2, y2, z2 the coordinates of our second point, and so forth. So we have 4 points. 3 dimensions, 4 points. Each of these is a point in 3 dimensions, and there are 4 of them. We get this. And that gives us the volume of a tetrahedron in 3 dimensions. So it's like we're in 3 dimensions. And we've got a point here. Say that point's above here. And then a point here, which is above here. And then a point over here, which might be above here. And another point here, which might be above this point in the xy plane. So we've got this irregular quadrilateral in the xy plane, and above that we've got this tetrahedron or 4-sided figure, and we can do a little shading. Here's the front of it, here's the top, which is kind of weird. It's sort of like the polyhedron and figures that we use in multivariable calculus, but it's not nearly as regular. It could be any weird shape, as long as it's got a rectangle in the, a quadrilateral in the plane. It's not a rectangle down here anymore. It could be anything. Okay? And if this is x1, y1, z1, x2, y2, z2, x3, y3, z3, x4, y4, z4, it gives us the volume. Now, what do we know if the volume of our tetrahedron is 0? Well, that means that our 4 points lie on a plane. Now I'm going to just do that by analogy and hand waving. And actually, I drew this wrong. This is not our tetrahedron. Our tetrahedron is obtained by connecting each of these points to each of the others. Okay, so here's our tetrahedron. It lies above here, but we're not talking about the volume below this, which is what I'm just talking about in multivariable calculus. So I said that kind of uncritically. But you have 4 points. If you connect them all, you get a 4-sided figure. It's not a regular figure, but it's 4-sided. Okay? If these 4 points all lie on a plane, then the four-sided figure is all in the same plane, meaning it's a two-dimensional figure, which means it has zero volume. Okay? So if the volume of the tetrahedron is 0, and this is analogous to having the triangle of zero volume, or zero area. A tetrahedron of zero volume means all 4 points are in a plane. A triangle of zero area means the 3 vertices are on a line. So it's kind of a neat exercise in some higher dimensional geometry. We can't visualize what would happen if you had 5 points in 4-dimensional space, but we can certainly calculate it. It's really easy to calculate. It's a little messy, but you're probably going to use a computer to do it anyhow. We'd add another coordinate here and another line, another row to our matrix, but it would look almost identical to this. We just have a W1, W2, W3, W4 column, and a W5 down here, and an X5 and a Y5 and some number over here. And I've got to stop writing things without thinking. These numbers over here are all 1. Started asking myself, what, how do I get 1, 2, 3, 4? No, they're all 1 just like they are here. Sorry for misleading you. Okay. We can also extend this to finding the equation of a plane. The determinant of x, y, z, 1, x1, y1, z1, 1, x2, y2, z2, 1, x3, y3, z3, 1 equals 0. Boy, I hate that Zoom just cut out on us. It wasn't Zoom, I'm sure it's my modem, and I am going to forcefully but politely insist on a new modem. Paying for the blame thing and it keeps going out. Okay. Either that or they fix their lines if that's what's causing the modem to crash. So unfortunately we lost our connection. Not going to bother trying to... maybe this was Zoom. Because now it tells me that the Zoom client was just installed. So maybe I don't have to take it up with my provider. But why in the world are they installing Zoom at prime class time? Somebody ain't thinking. And I don't think it's our people. Somebody needs to set that up a little better. If it's our people, I'll politely request that they do so. Anyhow, I can finish this. The equation of the plane through 3 points is going to be this. Determinant of this has to equal 0. This is because this expresses the condition x, y, z is on the same plane as x1, y1, z1, x2, y2, z2, and x3, y3, z3. Okay, it's on the same plane because this determinant is 0, which means the 3 points there are on the same plane. And of course, if it's x, y, z, an arbitrary x, y, z that's on the same plane, this is going to work for every point on that plane. So you're going to get the equation of a plane. Okay, let's see if there's anything else I wanted to do. Nope, actually got it all done. And we're about exactly 13 minutes over. And that's about the time we lost when my modem went down. Now Zoom decided to reinstall itself in the middle of my class without any warning. And I'm not real happy with Zoom over that. But at least I think we've got a fairly decent video of what you need to understand so that you can easily move through most of the problem sets that are going to be due a week from today.